Hello friends, and today now we'll be talking about the units of the rate of the reaction, that is the units of the rate constant, that is K. Very simple. First we are going to try and calculate the units of the rate constant for a zero order reaction, that is when the order of the reaction is zero. Very simple, we try and determine the expression for the K, that is the rate upon the concentrations raised to the order of the reaction, raised to the power of the order of the reaction. So in this case, the units of the rate is also always going to be concentration upon time, that is mole per liter per second. But the rate of your the units of your concentration is going to be changed according to your order of the reaction. So if it's a zero order reaction, the amount of the reactants present does not make any difference in the rate law, because anything raised to the power 0 is going to give you 1, which is negligible in our case. So everything is going to be determined by the K. So the sole responsibility of maintaining the units of the rate of the reaction as concentration upon time lays on the shoulders of K. So the units of K is going to be mole per liter per second. Now for the first order reaction, we are going to have the rate divided by the concentration raised to the power 1. So here simply, we are going to have the concentration upon time, that is the expression for your rate of the reaction, divided by 1 upon the concentration, because concentration is there. The amount of the reactant is going to make a difference in the reaction, because the power is 1. So simply the concentration and the concentration will be cancelled by each other, giving the units of the K, that is the rate constant, as a second inverse. Now if you have the same thing for second order reaction. Now in this case, again, the expression for the rate constant is going to be rate upon concentration of the reactant raised to the power, the order of the reaction. So as you all know, the units of the rate of the units of the rate of a reaction are always going to be concentration upon time, that is mole per liter per second. But in this case, the concentration, the concentration of the reactants is squared. The order of the concentration of the reactants is squared. So the final rate constants unit is going to be second inverse and concentration inverse, because that square value is there and this concentration raised to the power 1 divided by concentration raised to the power 2. So obviously it's going to cancel out one of the concentrations and only one will be left in the denominator, hence giving you the units of the rate constant as mole inverse liter second inverse. So this winds up our units of the rate constant. Now we'll try and determine the molecularity of a reaction. What is the molecularity? Speaking simply, when everything I was saying was coming true, that is in the elementary reactions, the number of moles of a reaction were actually determining the rate law. That is molecularity of a reaction. Molecularity in literal terms means that the amount of molecules that are colliding with each other in a reaction to form certain products. So there can be unimolecular reactions in which only one molecule is going through this reaction. There can be two. There can be two where bimolecular reaction is happening. That means two molecules are colliding with each other to go on through a reaction. There can be trimolecular reactions where three molecules are colliding with each other in a reaction. But it has been observed that reactions of a molecularity of more than 3 cannot occur, because simultaneously there not be that amount of space available for these type of rigorous collisions for a reaction to actually occur. So now if we have a very large order of a reaction, that is 10 or 11, you might think that what will happen in that case? First of all, the first thing that has to go in your mind in that case is that the reaction will never ever take place in one step only. The reaction is going to be divided into 2 or 3 or 4 or even 5 or 6, depending upon the how large the order of the reaction is. So it's never ever going to occur in a single step. It's going to have more than 2 or 3 or more than one step. Now, the rate determining, that is the rate law determining step, is going to be the slowest one. The slowest one in the entire series or the steps of the reaction. This is the molecularity of a reaction. I hope you have understood what is the rate law, how do we calculate the units of the rate constant, and what is the molecularity of a reaction, and how can we actually calculate the molecularity of a reaction. And if you want to know more about this chapter, you've got to see my other videos as well. That's all for the day.